Hello, my name is Douglas Castro. I am a second-year eBio PhD student at the University of Colorado-Boulder. Broadly, my research interests are looking at the ecological and biogeochemical implications of microplastic deposition in the Colorado Front Range, more specifically in the IPWA Long-Term Ecological Research Station. Microplastic deposition in the Colorado Front Range is primarily driven by long-range and short-range atmospheric events that intersect with densely populated areas. Here's a clip from one of my field days for more context. So behind me is a huge haze of pollution, largely driven by anthropogenic activity, things like agriculture, industry, and also residential, suburban, and urban activity. Every time you drive your car, your tires produce microplastics that have the potential to be suspended in the atmosphere. And when you dry your clothes, microplastics are emitted from your dryer, from your clothes, and are also emitted into the atmosphere. And so those microplastics that are floating up in the air have the potential to interact with metals caused by industry, and also interact with dust that's created by agriculture. So you get these microplastics with nutrients that are absorbed or toxic metals that are absorbed in the surface. And all that has implications for these sensitive mountain ecosystems. So that's why it's really important to understand what type of microplastics are being deposited in the IPWA LTER. So microplastic research is a relatively new field. As of yet, there are no standardized sampling methods, especially for subalpine and alpine environments. For the summer of 2023, I implemented two new sampling methods modified from previous research to take microplastics from samples of lakes, creeks, and solifluction lobes. Both sampling methods were implemented in the summer of 2023 with three goals in mind. The first was to just compare the sampling methods with each other to see which is the best fit for subalpine and alpine environments. The second is to get the microplastic concentration for each hydrological feature. And the third is to get the size distribution, the morphological distribution, and the polymer composition distribution of each hydrological feature. These parameters are key in understanding the toxicological potential of the plastics within their respective hydrological feature. One of the devices made was a microplastic collection net, which was completely funded by the Indian Peaks Wilderness Alliance. Here's a quick clip detailing some of its specs. So we made a completely stainless steel microplastic collection net with 304 stainless steel, an aluminum frame, and a flow meter on the outside rather than in. The flow meter does have some plastics, and we want to avoid self-contamination when we can. So what we'll do is we deploy this with a 38 micron mesh, which is the smallest of its kind. Like I said, in previous studies in marine settings, it's around 200 to 300 microns. So we are assessing for a much larger range, up to an order of magnitude of microplastics. And so what we'll do is we will take this net, bring it out when we're done with it, and we'll rinse from the outside in with a high pressure sprayer, and we'll make sure that the rinsate goes down into the collector. And then we'll take the collector out, we'll put it inside out in a stainless steel funnel, and from the outside in, spray again to collect that water full of the organic matter, sediment, and microplastics that we capture with this net. The second method was a peristaltic pump system, which filtered water through a 1 micron stainless steel filter. Now we'll discuss some of the results so far. As expected, the microplastic collection net was able to filter upwards of 30,000 liters more water than the peristaltic pump system. Now this is good news. Although the Colorado Front Range is highly impacted with microplastic pollution, we are still expecting to see relatively low concentrations in these hydrological features. So the more water we're able to filter through, the higher chances are of us getting above detection limit and getting meaningful numbers that actually tell us about the extent of contamination within the IPWA Long-Term Ecological Research Station. However, there is a downfall to the microplastic collection net. Because it is only 30 microns, we are missing the 1 micron to the 30 micron range, which unfortunately is really important in estimating toxicity of plastics within these aquatic systems. So, hoping to get around that by using the 1 micron filter data that I get from the peristaltic pump to kind of make up for that shortcoming. I have done some preliminary screening of the 1 micron peristaltic pump filters. Now, it looks like there are some suspect particles. And I'm hoping to confirm their composition using FTIR and LDIR in the spring of 2024. With this data, I can start to optimize my sampling methodology and lab processing to really understand the extent of contamination within the Colorado Front Range. Additionally, it'll allow me to really narrow down my questions on what microplastic contamination in these areas means for the ecology and what it means biogeochemically. I want to give a special thanks to the Indian Peaks Wilderness Alliance for their part in funding an integral aspect of my project. I want to thank the NIWA LTR and the NSF, the eBio department, the Colorado Mountain Club Foundation, and finally the Environmental Biogeochemistry Group and all my lab members for their support. Thank you everyone, have a good day.